Okay, I'm gonna take you through a couple of the challenges in the modern binary exploitation course for rpisec. I'm just doing this for just the first 5 or so of the challenges .zip. So feel free to go to this site and download that and follow along if you'd like. I'll leave the link in the description. Okay. So first I like to run the program naturally, just to kind of see what it does. Just some random crap here. And as you can see, it just is some sort of loop that keeps asking for input until you get the correct input. I like to use object dump to disassemble the program to see what is going on there. Just pipe this to less so I can scroll to it. Okay, most of this stuff's just like operator, like, well, not, I mean, it's like compiler stuff that was compiled. This is the actual program that the programmer made right here. It's just in the main, and that's the only function they used. So there's a string compare, and it looks like it loads in that, and then it loads in my output, and then compares it, and then tests it and jumps to whether, and it says whether or not you got it right, and then jumps back up if you didn't get it right. So nothing too incredible there. Since it does use string compare, you probably want to use the strings program in Linux and just call your function there. Probably should have piped that, but anyway, let's see. You got enter password, congrats, wrong, and I imagine it's probably this good job thing. So most likely that. So I'll try it with that just to see. And woohoo! Is most definitely that. Let's try B. See what this is about. So it looks like pretty much the same thing. I like to look at the object dump to see what I can do. To see what's going on, and what I probably should do actually. So there's that. So there is this. So after it gets the input, it says the stuff, you know, enter password or whatever, and then it does scanf, and then does this different string compare. It's a wide character string compare, I believe. But you can just look up all these functions online, and then here you go, wide char t. And if you look it up, I believe it's 32 bits, which is a good thing to know the size, because the strings function does give multiple different sizes that it is here in the encoding. Normally it just does the 7-bit string, But you can do 8-bit, 16-bit, and 32-bit. And I'm pretty sure it's just this long. I don't know what the B is. Wow, great. Copy that. Congrats! I did it! So they just did a, which is kind of nice because most people, if you're not good at hiding it as the programmer, most people won't think to use that other string's capabilities when they're trying to find it, in which case it will be all messed up. Be hard for them to see or find. I guess I could show you that. It doesn't actually show this. X O B grep. Wow. If you don't know what grep does, just filters it out based on the input you provide it, and it will give you nothing if there is no input, or if the thing given to it or piped to it doesn't have that in there. Okay, so what am I on? Crackme 01, I guess. Thought it was going to be a loop. So that's all fine and dandy. Oh, I guess I can delete that. I'll just show you that later. I was just deleting this cracked version I made to get past it, and I'll show you that later. It's pretty nice. It's kind of the way cracked games work and cracked applications work, is they basically just bypass the check function to see if you have the proper license or whatever. Anyway, I'm not condoning that. Don't do that. That would be very illegal. So object dump, so the disassembly of the program, you usually want to do that, and I'm on 01 that I'm testing. I could have piped that, I guess. So the frame dummy is exactly that. It's a frame dummy that's not really part of the program. It helps execution of the program. That's about it. So here, nothing special. This is the first print statements that you see if you run the program. Those first two. And then there's the scanf, which is expecting. That's the string format. That's past the scanf. And then it jumps as equal. So this is more than likely your input that you provide, and it's comparing it to 19A. So cool little thing you can do here is 149A, and it will give it to you in a decimal or string format, I guess, in which case it would be decimal, because it's gonna, yeah. And then you can try that 5274, And there you go. And I just got that from looking at this compare. It jumps this if equals to down here somewhere, and then prints whether you got it. And if it's not equal, then it runs and says that you don't got it, or vice versa. I'm not in a debugger, so I can't tell you which is which with that. So let's do 2 now. And nothing. Okay. Change this to 2. Okay. Again, frame dummy, so there's not really anything here. Printf, that's the first beginning crap that happens, and scanf. And I imagine that's taking a string because it doesn't seem to be crashing. If I give it a character or something. One EC, 5A. If not equal. So since it's taking registry values, I'm not going to be able to tell what that needs without using a debugger. So I'm just going to jump into Evan's debugger real quick. And if you're on Kali Linux like I am, you have Evan's debugger already. Just open up the file. And they have a little script. First of all, you're going to want to click run once to go to the beginning of main. And I like to analyze here to see what the different functions are. This is just a frame dummy, as I showed you earlier. And you can see that if you go into the symbol viewer, you can scroll down and you see main. You can click on the different ones. Frame dummies there. Main's at 3E4, 3E4. So nothing too special, right? But my curiosity comes with the stuff happening right around here. So just double click off to the side and it gives you a breakpoint. And then I'm just going to click run. And this is where it's being executed. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Sounds good to me. 2, 4, 6. That's probably not it. No, that's not it because it's multiplying. 52B24. So I imagine 52B24. I'm just gonna, because it looks like it's kind of doing the same thing. Okay. Now that I got that, that way I won't forget it, because that will change more than likely. And then it's comparing 52B24 with that, which must be what I passed it. So, as ridiculous as this is, all I have to do is say 338724, because that's what it's comparing before the jumps right here. So obviously in this situation I did not pass it that, so it won't pass the correct one. And as you can see, this is how you can 804.856F. You come down here to the data dump and you can see where it actually, what it's actually looking at, which is this stuff. Yeah, it was actually looking for a decimal value with the scanf, or not decimal, integer. And that one's done. So I'm gonna kill this and work on number 3. So that didn't seem to be anything. I'll check out what's in number 3. Crackme 03. There's this stupid shift function. And jump. Compare. Oh, that's the beginning of the loop. Let's see. Test. If equals compare. That might tell me what I need. See main. I'm betting that it's passing the value I need to the test function. So if I just jump in here to the into my Evans debugger again, and I'm on 3. If that wants to run. Anyway, what I was kind of saying earlier is you want to, with the symbol view, with the symbols, there's a little function on the Evans debugger wiki that will load, that you can run, that will load in all your different symbols that you have on your computer, because you have to have the different libraries, the different, like the different libraries that get executed. So printf is calling a library that's stored in your OS somewhere, probably in bin or something, but I can't remember. And then you can come into here, preferences, and set it symbol directory, just something a little nice to know, or else you probably won't be following along very well. Let's see, I'm going to break right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, whatever. Okay, so that's retarded, but let's check this out. I wonder if it's just straight up the same freaking thing, man. 338724. Wow. Okay, so 2 and 3 have the same exact password. Woo! They just thought they would pass it instead, and that would confuse you, but it's practically the same thing. So, yeah, kill. Let's do number 4 now. It's some text, and apparently I already got it right. So yeah, something like that. I don't know. Let's see. Play with it a little bit more, since I already got it. So that's interesting. Let's see why that is. 4. From dummy check. So here in the check function, this is like the beginning of the loop, compare, blah, blah, yeah, string length. It's like a for loop or something. It's adding this stuff. And then it's comparing to see if it is F. And F is, F is 15, so if you didn't know that, now you know. So since it's comparing, since it's adding my input each time to a total value, theoretically this string of ones should give me password OK. Yes. Now say I did it for 2, that shouldn't work because 2 can't go into 15, etc. So that's kind of, and you can debug this, and I did go into the Evans debugger the first time around that I went around doing it. But if you look at this compare right here, if it's not equal, it jumps down to the 804.8.4f and increments and jumps back up. And if it is, then it will run 2 through this exit function and the printf and whatnot, which is just happens to be the password OK. And this is the and you can verify this by looking at the data dump, but I'm not going to show you that because that one's easy enough, especially if you're like me and you do that. Then you just will happen to get it first try. But yeah, that's what I usually do. Just one of the things I do when I'm passing it randomness is just count up to 9 or 10 or 0 or whatever, I guess the logical thing, let's check out 05 now and see what the story is there. This probably helps if I do this or that. Oh, the reason, so I was looking for basically just, I probably should explain that better, looking for it to be added up to 15 here on Crackme 04, and once the input is added up to 15, it is then calls the printf and exits saying password OK or whatever. So as you see, 6 plus 4, 10 plus 5, there you go, 15. So that's why 1, 2, 3, 4, 5 works. 1 plus 2 plus 3 plus 4 plus 5. 5 factorial or whatever it is, or I guess it's not factorial, it would be the summation of I equals 1 and then ends 5 or some crap like that. I can't remember how those work. Okay, so this one's a little harder, and I can show you this pretty quick still. If you look at the data dump, has this parallel function that's called with the scanf, and then it tests the output and does the appropriate jumps. And I'm assuming this is the same thing where it calls the printf of password correct or whatever, and then exits or else returns. And this is called from in the right here in the check function that they have, and this is kind of like the last one without the parallel, where it has this string length compare, and then it's in a pretty much like a for loop or something. Runs down here, scanf again, but then right here there's this call to the parallel function that doesn't ever really get reached. So what you can do is you can do a nope sled right here and get rid of the jump of not equals, and then it will come in here and it will do the parallel, and I've found that you can pass pretty much anything to it at that point, and it will be after you know, if you just ignore this jump and force it down here, anything will go. And I don't know if they intended it to be done this way, but this is the way. I just figured this is a good thing to show you, because it's kind of the way they go about bypassing, like, having to enter a key into software and stuff like that. Is they just, depending on how they actually went about doing that, those programmers, but this is a possibility to get past some of them. Again, I'm not endorsing you to do that, but it is a possibility. I'm going to jump into Evan's debugger just so I could show you. That it's got a 5. I'm going to analyze here. Set breakpoint here at check, because this is pretty much doing nothing, right? It's just printing the beginning stuff and then getting your input and passing it to check. No big deal there. I'm just going to say, dude. It's ridiculous, but it works. And then I want to step into check, so just click step into. And it does all this. It jumps if above or equal, so put a breakpoint there, and you can see that the string length of mine should be 4. And then it will check to see if the EBP minus C is greater than that. And if it is, then it will jump all the way down here and say, oh, you didn't get it, blah, blah, blah. Which you can verify, 8048679. Which is right here. Password 6. Password incorrect. Yeah. But that's not what I want. So I'm just going to run down here. It's going to compare this. To see if it's 16. Oh. Does this jump that I was talking about, and then it won't go into that pretty much ever. I'll show you that. Set up some breakpoints right before the jump, and then here in case I mess it up. Got a breakpoint there, okay. And as you can see, so the jump will continue to be taken, and it will continue to not do the parallel. I already step out of. Oops, I accidentally went into it, into the string length. That was scary. Anyway, let's go back down to that jump. Okay, so I'm going to do, you can fill with nopes. It's all fine and dandy. Here's another thing you can do, and I'll show you the nopes. The nopes are just 90. It's just hexadecimal 90. So that's how you can do a nope sled. And I'll show you that in hex editor here in a second. Or what I like to do is set instruction pointer to this instruction. That way I have encountered sometimes where they have like a dummy function or a test function that they forgot to get rid of. And so it's still there in the program, even though that they have commented out where they are doing the test stuff, so therefore in the main portion of it, it doesn't get executed, but you can set this EIP to be it. So like I could although if it requires variables, it might not be too obvious what you need to do. But now that I've set it here, I'm not even going to jump into the parallel, because it's just going to run through the parallel and say, okay. So, having that been said, anytime so here in the check function, anytime that this jump not equals this right here, anytime that that's not taken, it will just pretty much say, okay, good password, once it hits the parallel function. That's like practically all it does. So, having that been said, you can look for this string and comment and change it into a nope sled, and you can do this with hex editor. Just press Control W. Search for hex bytes is what you want. I'm just going to copy this, Control Shift C, Control Shift V, then press enter, and there you go. And you want to verify that it is in the correct spot, because there might be another jump of not equals. Or whatever, but yeah. So 10, F8, 7, 8, 3, 10, 1, F8, 4, 5, 8D, FC, 5, 5, 8B. Yeah, it looks correct. So just simply type in the new stuff. 9090. Control X to exit and save. I'm going to say cracked, because I did crack it. As you see, it's not executable right now, so you need to make it executable. Now it is. If you run it, it's still going to execute, blah, blah, blah. But now I can say anything that I want. And it should. Oh, well, maybe not in that case. But most cases, dude. Is it just anything? I think it's any... Yeah, I think it might be any character. And it is okay. Yeah, that's what I'm thinking. Any character. And it's okay. That must be what that parallel function does. Check to see if it's a character. I didn't really look at the... I figured this would be a nice thing to show you. Because now, let's say if this was a piece of software that needed a password or a key to run it, Well, I found a way past it and I changed it, so now a hacker or whatever could just have that, you know. And also, they could inject this or whatever, so I could have a piece of code saying open up this, or open up a a connection to my computer, and then I could just inject these hexes here, just like I did for the nope sled, and I could inject that into the beginning of main or something, or have it call this function that does that, and then it would just be end game, right? But yeah, let's just see. Yeah, I think it's anything that has a string, or a character. Alright, thanks for watching. Feel free to comment, and I'll try my best to answer. I myself am still learning reverse engineering, so my answers may not be 100% correct.